Chain of events, cause and effect. We analyse what went right and what went wrong, as we discover that many outcomes can be predicted, planned for, and even prevented. I'm John Chidgey, and this is Causality. This episode is sponsored by Solver by Aqualia. Solver is an amazing calculation app that works the way your mind does when you're working out a math problem on paper. More powerful than a calculator, simpler and quicker than a spreadsheet, Solver can help you solve your math problem. Visit solver.app and check it out today. We'll talk more about them during the show. Causality is supported by you, our listeners. If you'd like to support the show, you can by supporting our sponsor or by becoming a premium supporter. Premium support is available via Patreon and through Apple Podcasts channel subscription. Premium supporters have access to early release, high-quality, ad-free episodes, as well as bonus material from all of our shows not available anywhere else. We're edging closer to our monthly goal to go advertising free across the network, but we can only do that with your help. Causality is also a podcasting 2.0 enhanced show, and with the right podcast player, you can also stream Satoshis and boost with a message as you listen. Just visit engineered.network/causality to learn how you can help this show to continue to be made. Thank you. Royal Canberra Hospital. The Royal Canberra Hospital was situated on the Acton Peninsula, surrounded by 270 degrees of Lake Burley Griffin. The original architect of Canberra, Walter Burley Griffin, had earmarked the site for a hospital on the Acton Peninsula, and construction began in 1912 in response to a surge in diphtheria cases in construction workers involved in the initial construction projects that formed Canberra at the time. The hospital grew with multiple expansion projects in the decades that followed. In 1989, the Steering Committee for Public Hospitals Development put forward a recommendation that the Woden Valley Hospital become the primary hospital for the Australian Capital Territory, that's the ACT. The Royal Canberra Hospital was ultimately closed on the 27th of November 1991 amongst some controversy, including a petition with 60,000 signatures opposing its closure, but ultimately being ignored by the government. On the 13th of December 1996, Project Coordination Australia Proprietary Limited, or PCAPL for short, were verbally appointed via the single select method, sometimes called a sole source agreement, by the government as the project manager for the site, as announced by the then Prime Minister, John Howard. Of note, formal award in writing came 6 days after the verbal announcement. Project Coordination was formed in 1975 and is headquartered in the ACT. And whilst it had a great deal of experience in project management of sites in the ACT, this would be the first implosive demolition within the ACT. Implosive demolitions were, and remain today, quite rare in Australia. They're typically used in older, tall structures, of which there are many less per capita in Australia for historical reasons than in some other countries around the world. In July 1995, a feasibility study was undertaken by Richard Glenn and Associates for the demolition and clearance of all buildings on Acton Peninsula, where the new National Museum would ultimately stand. On the 4th of August 1995, Cabinet approved a proposal that implosion demolition would be used, mainly due to this method saving approximately 1 month in clearing the site over more traditional methods of building removal, as well as reduced dust and nuisance to the nearby hospice that would remain operational, with a target completion date for the demolition of the 3rd of May 1996. The estimated cost of the demolition at that time was just over 8 million Australian dollars. With that background, let's talk about the incident itself. With a change of government and many other unrelated delays, the demolition date was finally set to be Sunday, the 13th of July, 1997. A crowd gathering on the grass nature strip near Lennox Gardens was estimated to be between 30 to 40,000 people. An estimated 100,000 people lined the banks of Lake Burley Griffin, some in boats, to watch the demolition take place. The buildings prepared for demolition were the main tower block and Sylvia Curley House. The demolition of Bennett House and the maternity unit were not flagged for demolition that day. As part of the spectacle, a brief fireworks display started at 1 p.m. on the main tower block, to be immediately followed by the demolition. However, falling debris from the firework display severed a firing circuit on the roof of the main tower block, halting the sequence. After repairs were made to the firing circuit at approximately 1:30 p.m., the implosive detonations were finally triggered. In the seconds following the first detonation, debris started landing in the lake, raining down on the spectators in their boats and along the shoreline. 3 seconds after the detonation of the corner columns of the east wing of the main tower block, a very large piece of shrapnel hit one of the spectators on the opposite shore. Some people applauded at the spectacle, not realizing that they were actually in danger. Other people that did realize they were in danger dove to the ground in an attempt to take cover, though there was little to no cover to be found for most of them. Trees and vehicles in the nearby area were also damaged by high-speed fragments of debris. On schedule, the second building, Sylvia Curley House, began its implosion sequence, first with fireworks, then with the implosive detonations. Following the demolitions, 9 people had been injured and were taken to hospital for treatment, and 1 was killed. Miss Katie Bender, aged 12, was struck in the head by an estimated 1 kilogram, 2.2 pound piece of steel shrapnel. She was standing nearly 500 meters away from the demolition site, far outside the exclusion zone set for the demolition. The investigation determined that the fragment that struck Miss Katie Bender matched the web thickness of an I-beam from either of the corner columns C30 and C74 of the main tower block. So why use implosive demolition? Richard Glenn and Associates were commissioned in May 1995 by the Construction Maintenance Management Services, that's CMMS, of the Department of Urban Services, DUS, to produce a feasibility study into the demolition and clearance of the Acton site. The initial RGA report was presented to Cabinet in August 1995. However, an addendum was produced in September 1995 and a further report was produced in February 1996. Of note, the reports had significant input from project coordination, who at that time had not yet been selected as the project manager and superintendent for the demolition, though it is clear that their involvement put them into the best position for sole sourcing of the project in the end. The initial report highlighted the additional protective measures required for an implosive detonation style of demolition and was a feasibility study. However, the February 1996 report contained significant suggestive technical detail about vibration, exclusion zones, siren usage, and photos of the St. Vincent's Hospital demolition in Melbourne by the same method from 1992. The report did not describe itself only as a feasibility study, and to the non-technical administrative people, it did not suggest any additional technical review would be necessary before selecting the implosive demolition method. The investigators noted for all of the reports provided that, and I quote, the RGA did not carry out any examination of the experiences held by Australian demolition contractors in performing an implosion, nor were any overseas specialist opinions sought, end quote. Of note, RGA were the project director of the demolition of the Convent of the Sisters of Charity in Princes Street. That was in 1992, which was part of the aforementioned St. Vincent's Hospital in Melbourne. It is unclear how technically involved they were with the design of that demolition, or if the same persons involved at RGA were involved with this feasibility study either. Having noted all of the above, the final design of the implosive demolition would still require independent review prior to demolition occurring. However, it's interesting how a feasibility study became an assess select report with a final recommendation, based on how you interpret the report from the perspective of the Cabinet, who are fundamentally non-technical people. Another important point, the submission to Cabinet was actually a summarized version of the initial report, which did not include the list of cautions and safety issues and presented implosive demolition as being as safe as more traditional methods of demolition. The investigators concluded that the Cabinet had made a decision on incomplete and inadequate information. Sole sourcing to PCAPL and TCL. Regarding the appointment of PCAPL, the investigation report states, and I quote, that the appointment as the project manager without any form of review is unsatisfactory, particularly as PCAPL did not have any relevant experience in implosion demolition. This inexperience in the implosion method was evident later when PCAPL did not take any steps to make a critical examination at the tender stage of the suitability of the implosion operator, his experience, and methods, end quote. In sifting through the testimonies, what's clear to me is that there were several meetings held prior to their appointment where they were invited, most likely due to their involvement in developing the RGA reports in the prior 12-month period. There was a change of federal government in 1996, and this triggered a time pressure from the new Prime Minister, John Howard, to get on with it. A meeting held on Wednesday, the 13th of December 1996, where PCAPL were recommended to be appointed as the project manager for the site, with the immediate task of securing the site with a temporary fence against possible occupancy by protesters or unions or against vandalisation. Whilst PCAPL were qualified in this regard, their ongoing appointment was never revisited despite the fact their experience in the actual demolition work of this kind was not sufficient. Sole sourcing is supposed to be a time-saving process that can only happen when a potential tenderer for a contract is fully pre-qualified and there is a strong case for their knowledge and experience to execute the works in question. Going out to tender is a long, drawn-out, expensive process, but it exists for a reason. All use of public expenditure is and should be subject to extensive scrutiny. What's clear in this case is that by conventional sole sourcing requirements, PCAPL did not qualify to be the project manager for this project in its entirety. In essence, they got their foot in the door, putting up a temporary fence, and stayed involved by momentum rather than qualification. The other party involved at this early stage of the project was Total Care Industries Limited, TCL, and had been appointed as the project director. TCL was incorporated in December 1991 and commenced operations on the 1st of January 1992 and is a wholly owned company by the Australian Capital Territory, which comprises the people and functions formerly from the Government Health Services Supply Centre, which had historically been operated as a branch of the ACT Health Administration. What did TCL have functional experience in to begin with? Well, there's linen hire, surgical instrument sterilisation, incineration of hazardous waste, motor vehicle repair, and building maintenance. In January 1997, several parts of the Works and Commercial Services group of the DUS were added to TCL, including property management, fleet management, building maintenance, surveying services, civil engineering maintenance and capital works, including architectural, engineering, and landscaping. That's certainly an improvement. How they were involved, though, was more analogous to that of an owner's representative, where the owner was the ACT government. In effect, the government outsourced the representation for the government to people that are actually independent but owned by the government and used to work directly for the government anyway. Sound like a bureaucracy? It's probably because it is. The sole sourcing to TCL is somewhat of a non-event, to my thinking, since the government does this sort of thing all of the time, and it appears to be more out of shuffling money between civil servants with very little difference to the final outcome. Ultimately, though, they aren't running the project itself. And like a lot of owners or owners' reps, they don't understand all of the technical detail. That has to lay with the engineering firms involved. Long gone are the days when the government maintained public works departments with skilled engineers of every discipline and insourced their own projects. Whilst pockets of expertise remain, the drive to outsource the work has been strong for many decades, and not just in Australia. Let's talk about the tendering process. Expressions of interest were advertised in the Canberra Times and the Australian newspapers on the 25th of January 1997. The expression of interest was drawn up by Mr. Cameron Dwyer, the project manager and superintendent working for PCAPL on the project, based on criteria from a previous construction project. Because of this, the EOI had no mention of the option of implosion or any other factor to suggest an interest in implosion either in the advertisement or the selection criteria in the information package. This was despite the fact that by the 13th of January 1997, both Mr. Gary Hotham from TCL and Mr. Dwyer were informed that implosion was an optimal method of demolition. Stage 1 tenders opened to the shortlist on Wednesday, the 3rd of March 1997 and closed on Tuesday, the 18th of March 1997. A shortlisted tenderers meeting was held on-site on Friday, the 5th of March 1997, when Stage 1 documents were released and a site inspection was held with a short list of drawings provided. It wasn't until Thursday, the 13th of March 1997, that the final structural drawings were made available as an addendum, and importantly, this addendum showed the positions and sizes of structural steel within the buildings. The Friday that week was a public holiday, leaving only 2 full business days to assess the final drawings before final tender submission, unless you worked the long weekend, of course. Probably not long enough, realistically, for a thorough review. Mr. Dwyer from PCAPL read and assessed each of the tenders upon their submission, and following consultation with Mr. Hotham, Mr. Dwyer prepared a recommendation report that recommended City and Country Demolition, that's CCD, submission be accepted. He wrote a further report summarising the advantages and disadvantages of implosion, and both were provided to TCL for review and final approval. The tender approval meeting was held on the 11th of April 1997. Interestingly, the tender required two pieces of information that were missing from the CCD submission that should have made it a non-conforming bid. There was no list of subcontractors they intended to use for work execution, and the work method statement mentioned implosion but didn't have any detail about what the work plan would be. During the investigation, both Mr. Hotham and Mr. Dwyer admitted that the submission was, and I quote, bare bones, and claimed they were relying upon a provision in the contract that required a work plan to be provided within 7 days of letting of the contract. In reality, they did not follow up on this until WorkCover Australia issued a prohibition notice after works had already commenced, 1 month post-award. Ultimately, therefore, the accepted bid was non-conformant and should never have been awarded to CCD. That said, had CCD submitted their intention to use controlled blasting services, that's CBS, with Mr. Rod McCracken, it is highly unlikely any investigation into prior relevant experience would have been performed, given the lack of depth of the tender reviews that was done. An international subject matter expert was consulted during this investigation, Mr. J. Mark Loiseau, the president of Controlled Demolition Incorporated of Phoenix, Maryland, in the United States. The Loiseau family have been involved in the demolition of buildings and structures for many decades and had imploded approximately 2,000 buildings, including 400 steel-framed encased structures at that time and many more since. Regarding the EOI process and advertising, Mr. Loiseau stated that his company had an agent in Australia whose role was to look for potential implosion work for his company, and that that agent did not become aware of the project until after the tragedy had occurred. The investigators concluded that the EOI was too narrowly focused and lacked important keywords that would attract people with the correct expertise to apply with an EOI, and had they found it and applied, the selection criteria may not have selected them for the shortlist. Regarding the tender selection of CCD, Mr. Loiseau stated that, and I quote, if proper checking of not only CCD but also CBS had occurred, Mr. McCracken would never have been given permission to do this job. End quote. If you're interested in how demolitions can be done properly and more about Mr. Loiseau, about 8 minutes into episode 3 of season 1 of a series called Blowdown, there's a link in the show notes. Give it a watch if you like. It's a bit overhyped, but demonstrative of the issues with steel in demolitions. I'd like to take a moment to talk about our sponsor for this episode, and that's Solver. Solver is a calculation app by Aqualia for the Mac. Now, I'm careful to call Solver a calculation app because it's more than just a calculator, and it's much quicker and easier to use than a spreadsheet. Just start typing away, and in real time, the answers show up in the right-hand column. Let's say you want to figure out 10% of 200. Just type that exactly, and there's your answer. Converting currencies, 10 euro plus 10 USD in AUD. Done. I use it for that all the time. Crazy things like you want to know how many minutes you've been alive, try 45 years, 5 weeks, and 4 days as minutes, and it turns out I've been alive 23,720,000 minutes. Yay, I'm so old. It's my go-to app when I'm converting between Celsius and Fahrenheit. 21F in C, done. A recently added neat feature I like is the ability to convert between Satoshis, Bitcoin, and to fiat currencies. That's very handy. And a great new feature, you can also now publish your worksheets and share them with anyone. Just hit share and copy the link and send it to whoever you like. Easy. Solver 3 for the Mac makes time and date calculations really easy too, like 30th of August 2021 to today, in weeks, in days, in hours, whatever you like. And Solver also supports time zone aware date and time calculations and conversions as well. You can link different result lines together easily to create more complex calculations with subtotals included. It now comes with full dark mode support and it looks amazing. And if you use a touch bar on your Mac, it supports that as well. Full integration with Spotlight Search with Automator, Solver now has a command line tool that integrates beautifully with Alfred. It has an integrated sheet management system, and you can easily share your working and get your results. The list of great features just goes on and on. If you're not convinced, then go to the URL in the show notes and check out the Mac version, which has a 30-day free trial. I've been using Solver for many, many years, and I use it every single day. Solver for Mac is available from the website solver.app as well as from the Mac App Store. If you use the URL in the show notes, it helps out the show. So please use that URL in the show notes to learn more about this amazing app. Visit solver.app and check it out today. Thank you to Aqualia with their amazing app Solver for once again sponsoring the Engineered Network. Let's talk a bit about the structural engineering. Mr. Gordon Ashley, a civil structural engineer, was engaged by Mr. Rod McCracken to provide an inspection in late May 1997 of works to date and, according to Mr. McCracken, to provide advice, and I quote, to ensure the columns remained as structurally stable and integral or with as much structural capacity as possible right up to the time the charges were exploded. End quote. Mr. Ashley's only prior experience in demolition of similar buildings was by induced collapse, whereby a weakened structure is either pushed or pulled over, inducing collapse, which is a very different method to the use of explosives. Mr. Ashley also had no experience in the use of explosives, let alone in their application to the demolition of a building. The investigators were confused why an engineer with 37 years of experience made no inquiry about the number of pre-cut columns during his inspection, insofar as which other structural engineer had approved those cuts. The reality was that none of the cuts had been reviewed by a civil engineer, although another had been involved in a query about bobcat usage. Mr. Adam Hugel was a civil structural engineer with 11 years' experience at that time, working for Northrop Engineers Proprietary Limited. He was engaged by Mr. Tony Fenwick of CCD on suggestion from Mr. Dwyer through previous works with Mr. Hugel on a different project, in an ad hoc arrangement at hourly rate. When Mr. Hugel was on site in early May, he was approached by Mr. McCracken out of Mr. Cracken's concern that a column had been overcut, and following a visual inspection, Mr. Hugel was horrified with the cutting that had already taken place. At that time, no structural engineer had provided design guidelines on how and where to cut which columns for structural pre-weakening, and no work plan had been submitted to the project manager either. Mr. Hugel sent a facsimile to CBS with a copy to Mr. Dwyer regarding the inspection of the first column with the following comments, and I quote, 1. We have not yet carried out detailed calculations to determine the amount of steel in the columns which it is safe to remove. We have carried out some indicative calculations of the load on the column which indicate that it has been overcut. The diagonal cuts in the steel UB at the center of the column should be butt welded together. 2. We have some concerns as to the overall stability of the building and need to work out a suitable mechanism for stabilizing the building prior to cutting steel from the columns. 3. The cutting of the steelwork is not being carried out in a careful and controlled manner and is being carried out without our involvement. 4. We cannot take any responsibility for any work carried out by the contractor without our involvement. 5. All future cutting of steel columns should only be carried out under the direct written instruction of Northrop engineers. 6. The cutting of the first few columns must be observed by Northrops to ensure that the columns are not being overcut. And finally, we confirm from our discussions this morning that you will be taking more care in future for preparation of columns for demolition. End quote. In response, Mr. Dwyer from PCAPL formally responded on the 21st of May to Mr. McCracken, and I quote, I have received a copy of a fax sent to Rod from Adam Hugel of Northrop Engineers dated 21st of May. The comments made by Adam are very concerning and require your immediate action and response. As requested by fax yesterday, I require a written status report of what work has been carried out to date, authority approvals, program, etc. In addition, please note that until I receive written engineer's confirmation of what steel columns can be cut and the extent, you are not to proceed with this work until further notice. Your urgent action is required on this matter. End quote. There is no evidence that CBS ever provided the information that Mr. Dwyer had requested, nor did they obtain written approval to continue with the demolition work, though they continued anyway. Mr. Hugel supplied additional recommendations to repair the overcut column and to cordon off the floor and cease the use of bobcats in that area as a precaution. The final facsimile sent by Mr. Hugel to Mr. McCracken was on the 22nd of May, 1997, where he reiterated Northrop's offer to assist further discussing rates and some upfront payment due to the short notice of their involvement. The offer was not taken up. Despite leaving 6 messages with Mr. Dwyer, his calls were never returned. Additionally, Mr. Dwyer sent another facsimile on the 23rd of May to Mr. Fenwick and copied Mr. Hotham from TCL, and I quote, "The client and I are concerned that the original advice from Rod McCracken regarding the use of a consulting engineer during the project has changed. The advice, which was taken into account when assessing your tender, was that he was engaging an engineer from Queensland who had been involved in the process of weakening the building structure prior to implosion. It now appears that he is utilizing a Canberra engineer with no prior experience in this area. This is not acceptable to either the client or PCAPL. It is critical that all work carried out in respect of weakening the structure is supervised by an experienced structural engineer with a particular area of expertise in implosion. I have no objection to the use of Northrop's for measuring column beam sizes. However, the specification for size of cuts into steelwork and the like must be carried out by his originally nominated engineer. Please ensure that the above instruction is followed. In addition, I require written confirmation from your organization that the engineer originally nominated by Rod McCracken is engaged on the project and is fully supervising the works carried out in relation to the pre-implosion preparation. Your urgent response in writing is required on this matter." End quote. Interestingly, a single entry in Rod McCracken's diary on the 24th of May reads, "Ring Neil Mackenzie, book ticket." So who was Neil Mackenzie? Mr. Neil Mackenzie of Neil Mackenzie and Associates was the originally nominated Queensland structural engineer to be involved in the project. However, neither he nor his company were formally engaged to provide engineering services, nor was he provided detailed drawings, or did he or anyone from his company ever visit the site. Section 4.2 of the ACT Demolition Code of Practice clearly states the following, and I quote, "Prior to commencement of demolition, the qualified structural engineer should have investigated the structure by whatever means necessary and have determined as accurately as possible the likelihood that the proposed methods and sequence of demolition can be executed without causing accidental collapse of the whole or part of the structure." End quote. Clearly, this did not happen. So how do you demolish a building? Explosively. Demolishing a building via explosive detonation, broadly speaking, has several stages. Firstly, clear the building of loads and clear the surrounding area. Then, prepare the structural supports, nominally columns by stripping concrete or weakening through cutting them, but clearly retaining enough strength so it doesn't fall on you while you're still inside it. Then strap explosive charges to key columns and wire them to fire in a set sequence. Build any protective walls around the columns and/or the building to protect anyone or anything from potential flying debris, and pull the trigger, I guess. In order to ensure the columns are severed, selected columns are pre-cut to reduce their structural integrity prior to the explosion. Explosions are then carefully timed between the columns, and there's normally a ripple pattern. The type of explosive used and how they're used broadly fall into 2 types, cutting and kick. Cutting charges are those that, perhaps as the name probably obviously suggests, cut through the remaining support members to break them apart. And kick charges are those that kick out the freshly cut section, effectively removing any support entirely and allowing the structure above to collapse under its own weight. Cutting charges are generally more powerful and can lead to flying debris, or what's simply referred to as fly in the business. Let's talk about the explosives that they used. Because the key concern for CBS was the proximity of the hospice, which was located on the landward side, and as such, great care was taken to place charges accordingly. Mr. McCracken stated that, and I quote, "Charges on the northern side of Sylvia Curley House will be positioned to eliminate the possibility of adverse fly material towards the hospice. The balance of charges will be placed to contain any fly material within the buildings where possible to do so." End quote. Rolled steel joint, or RSJ, is another name for steel I-beam. Following the site inspection, Mr. McCracken noted the following day that the hospital job might have RSJs encased in the concrete support columns. Mr. McCracken sent a facsimile to the US firm OEA Aerospace, formerly Explosive Technology, on the 28th of May 1997 regarding the specialized shape charges that he wanted to use on the job. The reply on the 6th of June indicated it could take between 4 to 6 months to produce the product if not already in stock, and for in-stock items, still between 1 to 2 months to have the charges ready for shipment, noting that shipment was expensive and slow via surface only. He then placed an order with the Sydney, Australia-based Applied Explosives Technology for between 500 to 700 cutting charges, enough for about 42.5 beams, despite the 5 to 8 week order time. The investigation found that the charges ordered were in fact not designed to be used on the bracing columns and the hospital, and had not been tested on them either. Hence, the investigators were unconvinced that McCracken had ever intended to use them on the Canberra Hospital demolition from a very early stage, despite them being mentioned in the work plan. When it became apparent that neither explosives could be delivered by the scheduled demolition date, Mr. McCracken chose instead to use cartridge explosives of Ryogel, with backing plates as a replacement for the cutting charges he had originally suggested. Mr. McCracken told the meeting on the 2nd of July 1997 that he was going to use 130 kilograms, that's 286 pounds of explosives in total, comprising of approximately 100 kilograms, or 220 pounds, of Ryogel, 12 kilograms, that's 26 pounds of power gel, and 18 kilograms, that's 40 pounds of PE4. So what are they? Ryogel is a product name for a water gel explosive available in cartridges. Power gel is a brand name for a range of explosive products that are emulsion-based, mostly containing ammonium nitrate. PE4 is the United Kingdom and Australian near equivalent for what the United States refer to as C4 explosive. It stands unimaginatively for plastic explosive number 4 and uses a different plasticizer than C4 but functions in much the same way. It is a high-yield explosive that can be sculpted into shape with the consistency of a soft clay. In the same meeting, Mr. McCracken stated that he would, and I quote, put in place 50% more sandbags than he had originally planned to give higher safety, end quote. Photos taken 2 hours before the detonation, although they were developed afterwards, this was the days of film photography after all, showed that many locations with no sandbag protection whatsoever, including around columns C30 and C74, being those columns most likely from which the lethal fragment had come. The investigators also noted that the ledges around the outside columns on the upper floors had been removed in preparation for the demolition. Hence, it was not possible to sandbag around the entire circumference of many of the external columns. The final amounts of explosives on each of the columns ranged from between 1 kilogram to 8 kilograms, that's 2 to 18 pounds, with no fly protection provided in any areas. So, how much explosives did they use? On the 10th of July 1997, the Canberra Times ran an article with a direct quote from Rod McCracken stating, Mr. McCracken said yesterday that the 225 kilograms, that's 496 pounds, of explosives to be detonated has all been laid, spread through the tower block and Sylvia Curley House in 280 positions. The next day, the 11th of July, Mr. McCracken told Mr. Mazza that for the main tower block, he had used lower ground floor, 1.7 kilos per column, ground floor, 1.3 kilos per column, and that added up to 224.5 kilos for the main tower block alone, and that didn't include Sylvia Curley House. Also on the 11th, Mr. McCracken purchased another 100 kilos of Ryogel cartridges. It's another 220 pounds. The next day, on the 12th, Mr. McCracken purchased another 75 kilograms. That's 165 pounds of Ryogel. On the day of the incident, on the 13th, Mr. McCracken told police that he had used somewhere between 480 and 500 kilos. That's 1,100 pounds of Ryogel in total. The late changes were never adequately explained, though it's clear the preference for Ryogel cartridges was driven, in part at least, by their relative ease of availability. Mr. McCracken stated that his overall plan had changed 4 or 5 times, but due to poor record keeping, investigators were unable to determine exactly how much of which type of explosive was actually used where, on site, on the day of the detonation. Mr. Loazo, in his expert assessment during the investigation, stated that he would expect a change in quantity of, and I quote, as little as 10% would require a formal notification, end quote, to the relevant parties. The fact is that Mr. McCracken did not formally notify anyone of the design change, nor was the design or the changes to that design ever formally reviewed. So to summarize the explosive situation, not trying to be funny, the amount of explosives used on the 13th of July versus what was indicated was almost 4 times as much as the original design had disclosed. The shot firer, Rod McCracken, had not used Ryogel cartridges before, and cartridges are not recommended as cutting charges on steel due to the very high likelihood of fly. Mr. McCracken had never used backing plates in this way on any prior demolition, nor did he test them on loaded columns of this type with the explosives that he would ultimately use on the day. And let's talk a little bit about the bunding. On the lake side of the building, there was a bund wall built for the demolition. It was ultimately too low to capture significant debris coming from the ground floor and was too low to catch all of the debris from the lower ground floor. Besides its height, there was a gap in the vicinity of column C30. That was intentional to allow for the chimney to fall, and it did not even extend across far enough to reach column C74 at all. The photographs on the day showed the absence of any protective measures along the face of the building. The investigators engaged Dr. A. Christic from the Defence Science and Technology Organisation, DSTO, Department of Defence from Salisbury in South Australia, to provide expert analysis of the projectiles implicated in the death of Katie Bender. During the investigation, Dr. Christic stated in evidence on the 24th of March 1998 that 4 or 5 metres of bund wall might have caught the fly that scattered over the crowd of onlookers. On the 10th of July 1997, 3 days before the detonation, Mr. Dwyer responded to a query from Mr. Peirce, who was a work cover inspector, stating, and I quote, "We confirm bund walls approximately 2.5 to 3 metres high will be constructed to the northern side of Sylvia Curley House where required. Our contractor has advised that the bund walls are not required along the full length of the building and will be formed where necessary to eliminate fly rock and minimize noise." End quote. Given that the bund wall did not resemble that on the day, it's unclear if they intended to complete the bund wall or whether this statement was incorrect, and it was never their intention at all. I'd like to take a minute to talk about the network and how you can help us out. The Engineered Network launched in 2015 and has several shows that take varying levels of time, effort, and research to prepare for, as well as to record, edit, and release for you, our listeners. Over time, the ways people can support the network have evolved. Initially through sponsorship advertising, which we're trying to move away from, we're now moving to a listener-supported approach. To that end, we've had a Patreon since 2015, and there are 6 support tiers, each with different benefits available to you. Basic supporters are for those that want to contribute something as a thank you for what we do here. It's our most popular support category. Named supporters and above get their name added to the Engineered Network homepage as a thank you. Premium and above levels are where it gets interesting. As a premium supporter, you'll get access to higher quality encoded audio files of all of our current shows, ad-free, and released before the public versions go live. Then we move into our producer levels, silver, gold, and platinum, all of which get a name mentioned in the episode audio itself and in the episode show notes. Gold and platinum producers are allowed to influence which topics the shows create, so you can have your own say in what we cover on our shows. Apple Podcasts now has the equivalent of our premium level in the Engineered Network channel subscription, all the same content that exists for premium and above patrons, but via the convenience of Apple Podcasts. Finally, we also support streaming value with Podcasting 2.0 enhancements. These allow you, the listener, to stream Satoshis, that's Bitcoin Lightning if you're into all of that, and by using the right podcast client app, you can stream sats in real time as you listen, and boost bonus value with a personal message if you like, whenever you like. You're in complete control. So if you're a fan of any of our shows and you want to help us out and ensure episodes continue to be made, there's lots of options that you can choose from. And no matter how much, what level, or whatever way you like, know that it is all very much appreciated and it makes all the difference. Thank you. The inquest into the death of Katie Bender began on the 25th of March 1998, concluding on the 11th of June, and delivered a 307-page report. In their summary, the inquest stated that the detonating explosive charges intended to implode the main tower block of the Royal Canberra Hospital employed an incorrect demolition methodology and listed 10 errors. The use of an excessive amount of explosives, the use of the wrong type of explosives, the use of a steel backing plate rather than a soft backing cover such as rubber, incorrect cuts made to the columns, failure to use cutting charges together with kick charges to correctly pre-weaken the steel columns, a failure to retain on a continuing basis for advice a structural engineer experienced with implosion process of demolition, a failure to retain for consultation or advice, again on a continuing basis, an independent explosives expert having knowledge on the implosion method of demolition, placing the explosives on the incorrect side of the steel column so that the blast was directed at the spectators on the other side of the lake, inadequate protective measures, and inadequate testing. The Acton Peninsula project failed systematically in that the contractor and subcontractor were insufficiently skilled for a complex project to be completed in the time schedule applicable. The project manager's representative was inadequately skilled for the task, which was not a simple routine construction site to which his prior experience applied. The government regulatory bodies failed to exercise their roles in a visible fashion. Senior officials of the CMD and the Chief Minister's media advisor with no knowledge of the demolition process played a prominent intrusive role that was wholly unwarranted in what was a commercial industrial project, and the project did not have the benefit of a structural engineer and an explosives demolition expert in accordance with the Demolition Code of Practice, both independent of the contractor, subcontractor, project director, and manager, that is, two experts at arm's length from the total demolition process. The report went on to add that the methodology used was a disaster in waiting for these reasons. The evidence was that the steel was mild steel of the kind generally used in the construction of buildings of this type. The use of this type and amount of explosives against steel in this fashion resulted in fragmentation entirely consistent with what would be expected. The method of cutting the columns, half-moon cuts, combined with the gearing effect of oxyacetylene cuts and the weight of the building meant that the columns could never have kicked out as intended. The quantities used were clearly excessive, the protective measures were virtually non-existent, and the blast was in the direction of the crowd across the lake, and the possibility of flying fragments being produced was well known to Mr. McCracken. Finally, the exclusion zone was set based on a figure of twice the height of the tallest structure and was never challenged during the project. Let's talk about the aftermath. A memorial to Katie was built in Lennox Gardens overlooking the Acton Peninsula, near to where she fell after being hit by the debris. Rodney Douglas McCracken was fined 15,000 Australian dollars under ACT health and safety laws. The manslaughter charge against him was dropped. That verdict took 6.5 years following the incident to be delivered. 20 years after the incident, Mr. McCracken still held a demolition endorsement within the ACT, but is now retired. So what do we learn from all of this? There's 3 points I'd like to touch on. Minimum oversight, competency, management of change, and time pressure. Let's start with oversight. It's not enough to simply have someone to review and look over documents and provide a stamp of approval. They need to have a minimum technical understanding of what they're looking at. It's very clear during the course of the project there were multiple corroborated statements made by the shot firer that showed the design was fluid and changing. And that's a red flag to stop the job right there. A technically well-reviewed design is solid and generally doesn't change materially as it approaches implementation. The question is, did all of the other people involved actually understand what a material change would look like for an explosive demolition project? Watching the explosive quantities increasing with each subsequent meeting, every passing day, and in every conversation is pretty obvious to me, but something I read in a few places in the document was the confidence and the apparent competence of the shot firer, Rod McCracken. Standing up and challenging someone that's technically knowledgeable in an area that you're not is very daunting. However, all it would have taken was for someone in the meeting on the 2nd July to have stood up and asked for a written design change note for the work plan. It could have changed the outcome completely. With management of change, it comes up time and again. A change is made to the design and it isn't reviewed. But then again, in this case, was the design ever actually reviewed by someone competent in this kind of demolition? There were 2 structural engineers briefly involved, a third that was supposed to be engaged but never was, and it seems like none of them ever spoke to each other. There's little question that Rod McCracken drove the explosive design, and the amount of review that the design had was minimal. But the fact that changes were made ad hoc, undocumented, immediately leading up to the detonation demonstrates a complete lack of any change management process. There simply wasn't any, and that's not acceptable. Finally, time pressure. As I've said before, time changes risk. Time pressure drives poor choices. The right charges from the USA would have taken a significant time to show up. The more proximate charges from Sydney would also have taken too long to show up. The bund walls could have been built much higher if they'd had more time, so why did it have to be that day? It could have slipped. Ultimately, though, those time pressures pushed the decisions down the wrong path. If a fair, open and realistic technical assessment had actually taken place, they would have exposed the trade-offs being made between poor, time-driven, explosive and bunding choices. Or they could have pushed for a significant risk reduction by pushing off the works for a few more weeks so it could be done safely, but they didn't. Despite the fact that there was widespread condemnation of the ACT government at the time, led by Ms. Kate Carnell, for turning the implosion into a public spectacle, I don't think that reducing the fanfare would have necessarily changed the outcome. Whoever was standing where Katie was when she was struck by the debris, even in a crowd half that size, it's still likely that someone would have been killed. The roadway where debris rained down was in gridlock at the time, and cars were damaged and people were injured. So unless they'd extended the exclusion zone to over a kilometre or 1,100 yards from the hospital site, closing those roads, the bridges and everything else, they still wouldn't have prevented an incident. Certainly, a larger crowd increased the odds of someone being killed, but it didn't help. And intentionally advertising it wouldn't have stopped the outcome. Then again, a less public spectacle would have made it easier to slip the project to the right and delay until the right explosives could be sourced. So I'll concede that, if only a risk assessment had actually been done properly, which it hadn't. Had the demolition been done properly, the exclusion zones would have been fine, and no one would have been injured. The failing comes back to how the demolition was carried out and how it was mismanaged. Having said all of that, the easiest way to have prevented this was fixing how the job was tendered and awarded in the first place. If I'm putting out a tender for anything, I want to see proven past experience in the field that I'm interested in. I want names and I want references, and I want to speak to those references and ask them to describe exactly what that company did, how well they did it, and whether they think I should give them work. I don't want to take on risk because I'm picking someone without the right skills or a company that has no depth when I need it. So-called equivalent experience isn't always equivalent, even though it sounds like it is. It can be subtle, but it matters to get it right. In this case, someone that's demolished a bridge is different to someone that's demolished a building in the same way that someone that's wired up a house electrical switchboard is different to someone who's wired up the electrical in a vehicle. They're kind of similar, but they're not really the same thing. Katie's life was cut short in a wholly preventable incident, and that is truly horrible. This isn't just about me telling a story of how this could be prevented, because anyone could do that. I truly hope that the people that need to hear this, the people that work in government departments, companies, organizations all around the world that are issuing scopes of work, expressions of interest, running a tendering process, I hope that some of them are actually hearing this, and I hope that they are actually listening, because situations like this just shouldn't happen. So don't let them. I'd personally like to thank Solver by Aqualia for sponsoring the Engineered Network. You've tried a calculator and a spreadsheet, but if you haven't tried Solver yet, you're missing out on a great app that fits perfectly with the way your brain actually thinks. Solver 3 for Mac is available from the solver.app website as well as through the Mac App Store. If you use the URL in the show notes, it helps out the show. So please use that URL in the show notes to learn more about this amazing app. Check it out today. If you're enjoying Causality and want to support the show, you can by supporting our sponsor or by becoming a premium supporter. We're edging closer to our monthly goal to go advertising free across the network, but we can only do that with your help. You can find details at engineered.network/causality about how you can help this show to continue to be made. A big thank you to all of our supporters. A special thank you to our silver producers Mitch Bilger, John Whitlow, Kevin Kosh, Shane O'Neill, Oliver Steele, Leslie Law Chan, Hafthor, Jared, and Bill. And an extra special thank you to both of our gold producers, Stephen Bridle and our producer known only as R. Causality is heavily researched, and links to all materials used for the creation of this episode are contained in the show notes. You can find them in the text of the episode description of your podcast player or on our website. Causality is a podcasting 2.0 enhanced show, and with the right podcast player, you'll have episode locations, enhanced chapters, and real-time subtitles on selected episodes. And you can also stream Satoshis and boost with a message if you like. There's details on how, along with a boostergram leaderboard on our website. You can follow me on the Fediverse at Chigi at engineered.space, on Twitter at John Chigi, or one word, or the network at engineered_net. This was Causality. I'm John Chigi. Thanks so much for listening.